G'day again, back for some more Year 10 June revision. We're just looking at some trigonometry. So this is the third part. This one we're going to look at the area. So what's the area of that triangle? You should recognise that as half AB sine C. So half multiplied by 7 multiplied by 8 multiplied by sine 40. Pretty straightforward, and you should be able to do that. So on your calculator, just half times 7 times 8 times sine 40. Punch, punch, punch. We'll just grab a calculator. Back with the calculator now. So 0.5 times 7 times 8 times sine 40, and we get 17.998. So there we go. 17.998, well, pretty close. 18, let's say they were centimetres. So this will be centimetres squared. And you're done. G'day again, back for some more trigonometry. So, show that sine squared theta plus cos squared theta equals 1 using the given triangle. Should be pretty straightforward. All you've got to do is figure out what is sine theta, what is cos theta, and then square them one at a time. So what is sine theta? Sine is opposite over hypotenuse. So if this is theta, we want opposite over hypotenuse. So we're going to go sine theta equals 4 over 5, cos theta equals adjacent over hypotenuse, 3 over, 5. So now we've got our two sines and coses, we can just put them in there. So sine squared theta is going to be, so sine squared theta will be 4 times 4 and 5 times 5 will be 16 over 25 plus cos squared theta will be 9 over 25, 3 times 3, 5 times 5 equals, well, 16 plus 9 is 25, look at that. 25 over, same base, 25, and that equals 1. And you're done. Pretty straightforward. G'day again. Back for the same question. This time I've got A, B and C, and it says show that sine squared plus cos squared equals 1. And there's no numbers. A little bit trickier, but you can do it. So again, sine squared equals opposite over hypotenuse. So we won't bother writing it all out again, but sine equals B over C. So we're going to write B squared over C squared plus, what's cos? Well, cos is adjacent over hypotenuse, plus A squared over B squared, also over C squared. Oops. Same hypotenuse, that hasn't moved. So now we've got sine squared plus cos squared, and we're going to add that together. So this is just B squared plus C squared, so that's going to equal B squared plus C squared, B squared plus A squared over C squared. Now you're going to think, hang on, I haven't got 1, I've got B squared plus A squared over C squared. Now you've got to do a bit more thinking and think, okay, this must equal 1 because I just proved it, just with numbers, this has got to equal 1. What can I think of to add to this to make it true? Yeah, I don't know. Well, yeah, you do. You know that this squared plus this squared equals this squared because that's Pythagoras. So from this triangle you can say Pythagoras says A squared plus B squared equals C squared. And you go, hang on a second, I've got B squared plus A squared. So from here, you can put a little arrow, and so that now equals C squared over C squared, which equals 1, and you're done. G'day again. So back to show you another thing about trigonometry. We're still doing Year 10 revision, and this time I've just said, you've got 30 degrees there, you've got a B there and a C there. We can put an A there if you want, but it doesn't really matter. What is sine 30? Well, sine 30 here is B over C. So let's write that down. So sine 30 equals B over C. Okay? Opposite over hypotenuse. Pretty straightforward. Should have a degrees on that. What's that angle there? Well, if that's 30 and that's 90, there's only one other number that can fit there, can't it? Because it's got to add up to 90. That's got to be 60. So let's think about what can we connect this to these two? Well, what if I say, what is cos 60? What's cos equal to? Cos equals adjacent over hypotenuse. So cos 60 must be B over C. And if you press those on your calculator, you get the same number. You press that, you actually get a physical number, and they're both the same. And you find that every connecting number is the same. So if I say, what is cos 1? Well, that's going to equal sine 89, because I can put them on either end of the triangle and they'll still be the same position. And you can do that on your calculator and check it out. And any combination of those, where they add up to 90, the sine will equal the opposite cos. Keep that in mind.